Okay, so we have been discussing about electrostatic forces, electrostatic field, and we have covered potential energy concepts. Okay, so today we will be seeing more in detail about that. So last class we have seen also the relationship of field and potential and many other things, right? So we have understood concepts, right? So we have to see some important results. So let us take up some important results of field as well as potential. So parallelly we can try to do some calculations of field as well as potential. There are many results, right? Particularly the results of field we have already noted, right? And some of the results of field we will be discussing in Gauss law, right? So but let us cover some important results. Let us take with a uniformly charged ring. Okay, so let us take about a uniformly charged ring. Uniformly charged ring. So suppose this is a uniformly charged ring, and let us consider the axis of this. We can consider this axis, and O is the origin is the center, and radius is r. So you want to find out field at some point on the axis at a distance of x, right? You want to find out the field at this point. Not only field, we also want to do calculation of potential. Both things we want. So let us first calculate field. Okay, so to calculate field, what we need to do, we need to calculate field. So field is defined particularly for point charges, but here the charges are not point charges. What we will do, we'll cut a small element and then we'll calculate. So let us take a very small element dl, and it will have a charge of dq, which is lambda into dl. So total charge is capital Q. So due to this point charge, here there will be field created, which is dE, and let us note this angle as theta. Note that this point is on the axis of the ring. So for each element on the ring, this distance is fixed. So this angle is also fixed, right? So because this is a point on the axis, any point on the axis is equidistant from the ring because it is symmetrical. Okay, right? So let us calculate this dE. D is k dq by this distance. Let us write this distance as z. So kq dq by z, or if you want a small r, you can also write this as a small r. So k dq into small r square, right? Now dq we can substitute as lambda into dl, lambda into dl into r square, right? Okay, then what else? We have to integrate it. See, I think you don't even have to do all this because you can clearly see that k is anyway constant. This dq is a small element. R is also constant because this point is same distance, right, from the element on this. So same r is small, r is also constant. So dq is only variable, but note that the field you have to resolve into two directions, right? Because field is a vector, you want to add this, so you have to resolve this into dE cos theta, and this will be dE sin theta. So when you are integrating, you have to integrate both the component. This is the small component along x-axis, dEx it is, and this is the small component along y-axis, right? We have to integrate both of them, right? Let us try to integrate, but note that while you will be integrating all this, there will be opposite element come this side, there will be one opposite element also this side. Like here this element is there, similarly this side one element will come, and this element which will come here, it will also try to create its field like the same manner. This is also dE. It will also create this side dE cos theta, and then it will also create dE sin theta. So you will be seeing that this dE sin theta components will get cancelled. Ultimately you will be getting only horizontal component, so you have to integrate that dE cos theta. So that means electric field along x-axis is dE cos theta. You can integrate this. dE is k dq by r square into cos theta. Note that everything here is constant. So cos theta r square, you have to just integrate dq. dq integration will give total charge. So cos theta can be written as base by hypotenuse. So x by r square r cube into total charge. This is what the net field which is along the x-axis. Now this field can also be written as k q x r cube. R is under root x square plus a r square, so it can be written as power 3 by 2 x square plus r square. Clear? Right. So like this we can write it. 1 second. Yes, Chatresh, can you hear me? Chatresh, are you able to hear me? Yes. Check your mic. Chatresh, are you able to hear me? Good evening. Okay, so we just started this uniformly charged ring. So today we are going to cover this important results on field as well as potential. Parallelly, we will cover. Okay, so uniformly charged ring, total charge is q. So on the axis we are taking a point. So due to this element, there will be field in this direction. This we can take components along x-axis, y-axis. Similarly, an opposite element will also create similar field. So field along y-axis will cancel out, only field along x-axis will leave. So that you have to integrate. So dE cos theta, we are not writing 2 dE cos theta. Why? Because we are taking dE cos theta in entire ring we are integrating. If you take 2 dE cos theta, that is half ring you can do. But instead of that, dE cos theta we are taking, because for each element is contributing dE cos theta. That dE cos theta we are integrating over the entire. Okay, so dE cos theta you integrate and substitute. Everything is constant, only dq is the variable. Dq integration will give total charge, and then r, which is root under x square plus r square, you substitute. This is a very important result. Okay, so now you know, previously we have just written this result, now we have proved it. Okay, so this is the result. So in your board exam, proof will come, you have to write all this detail, also with proper statements you have to write. Okay, this is the field. Then what else? Okay, so we got the field. How to get the potential? Potential also will do, but before going to potential, let us think about the maximum field. What is the maximum field? Where is the maximum field, and what is the value of maximum field? So to get the maximum field, you have to differentiate dE by dx and equate to 0. For maximum minimum, you know, differentiation should be 0. So let us do that. For maximum field, for maximum field, dE by dx, dE by dx is equal to 0. Differentiate that, kq comes out. Now u by v, it is u by v differentiation, you know, u by v, u by v differentiation, you know, right? It has to be 0. So u by v means v square you have to do, so x square plus r square whole square means it will become 3. Then what? Then leave this, leave the denominator x square plus r square 3 by 2, differentiate the numerator which is 1 minus minus leave this x, differentiate this, so this is 3 by 2, this power, this minus 1, so do that, minus 1 means root, it will be x square plus r square power half, right? Then what else? Then chain rule you are using it, so this 2x also will come. So this is the differentiation, you have to equate to 0. Try to solve this, try to solve this. So this will multiply 0, that's only this term will remain, so x square plus r square power 3 by 2 is equal to this, you take that side, 2 get cancelled, so 3x square x square plus r square power half. Now half power and this will get cancelled, so 3 by 2 minus half means power 1, so x square plus r square is equal to 3x square. So from here you are getting that 2x square is equal to r square. So from here x is equal to r by plus minus r by root 2. Now this is an important result. Important result. So that means when x is plus minus r2, there will be maxima minima, either maxima or minima, because you know at maximum minima dy by dx is 0. So the differentiation is 0 means either maxima or minima will happen, because we have got two roots. Where is maximum minima? You can substitute it here also. If you substitute x here, this x square term will be positive. Here x is power 1. So plus x means plus value means maximum value, minus value means minimum value. So let us try to draw the graph of this field. How does the field look like? Field versus x graph. If I draw, how does it will look like? When x I am taking 0, so field is definitely 0 here. X0 means field 0, and positive means maxima will come, negative means minima will come. So I think this graph may go like this. I mean, negative side, this graph will be going like this way. Symmetric graph will be there. So this maximum value and minimum value happens here. This is r by root 2 and this is minus r by root 2. So you can see that here the value is minimum value and here the value is maximum value. So the field is maximum here and the field is minimum here. Now what is the value of maximum minimum? Now you can substitute this here. So let us calculate maximum value. Magnitude is same but plus minus is there. So what is the maximum field? KQ r by root 2 divided by r square plus that. So r square by 2. Those 3 r square by 2 power 3 by 2. How much it will come? Let us simplify this. What will happen? Find out. 3 by 2 means what? 3 by 2 means 1 and root. Okay. So k r by root 2. So one time you write and one time you take root. Root means root under 3 by 2 will come and r will come out. Okay. So basically what you can see here is you can cancel r, this root 2 will also get cancelled. Okay. Yes, what will be this value then? This value will come, 2 will come and 3 root 3 will come in denominator. other thing is k cube by r square will come. So you need to now remember for NEET as well as J this important result, we must remember that. So 3 root 3 in denominator and 2 in numerator. So 2 by 3 root 3, this factor you remember. 2 by 3 root 3 k cube by r square. That is the maximum field, right? My minimum is put a minus sign, that's all. So this is the maximum field or minimum field that can exist along the axis. Now this has got application. What is the application? Very important application is there. For stable equilibrium and unstable equilibrium, that also we can calculate. Remember, the stable equilibrium means if you disturb the particle from that position, it will try to come back to that position. That is called stable equilibrium. Unstable equilibrium means if you disturb the particle from that position, it will never come back to that position, it will go away, right? So these results are important because wherever field is maximum, what can happen to the potential or potential energy, that we will see that. Okay, right? So right now we have got this result. What is the formula for field proof and what is the maximum field and where is the maximum field happening? Clear? Yes. Now let us calculate potential. Potential due to that ring, same ring. Let's finish out this ring one. So potential. How do you calculate potential at the axial point? So suppose if I take any point here, which is at a distance of r here, this distance is capital R and this distance is x. This is theta. So at this point, what will be the potential? And this is charge, uniform charge distribution is there on the ring, plus q. So due to a small element, same approach, we'll calculate the potential. Potential here will be k dq by r. Now remember that potential is a scalar quantity that you do not have to take components and do all that. Potential is a scalar quantity which you need to simply integrate because it is a scalar quantity. It is not a vector quantity like field which you have to resolve. You don't have to resolve anything. You have to simply integrate this to get the resultant potential. So integrate. So k by r, you have to integrate dq, that means the total charge. So k cube by simply r. Okay, so k cube by this r is nothing but root under r square plus x square. So the potential is equal to k q by root under r square plus x square. That is the formula for potential. And if you will ask where is the potential maximum, so wherever denominator is minimum and denominator minimum can be x equal to 0, so at the center potential is going to be maximum. So at center x is equal to 0, potential is maximum, which is k q by capital R. Okay, so we have maximum potential at the center, right? This is all about potential. Very simple. Potential does not have much complexity. Okay, but what about if we take some question of charge and try to find out whether it is whether it will be what kind of equilibrium it will be, you can think about it. Okay, what are the question? Some textbook have this question. Okay, one textbook I have seen this type of question. I don't know whether you have seen or not, but check. this question, it is given like this, and this is the axis, this is the origin, center, this is radius r, total charge is q. They are saying that there is a particle of a small q and its mass is m. Right now it is in equilibrium. Right now it is in equilibrium, and if you disturb it from that equilibrium position, what will happen? If you disturb it from that position. And question is that equilibrium stable equilibrium or unstable equilibrium? What kind of equilibrium it is, right? Think about it. So that means first also you think about the forces. When you say equilibrium, you have to see the forces also. What forces are acting? So on this charge, what are the forces which are acting? So just now we have seen, let us say this is a positive charge. So this ring will be creating a field like this in this axial direction. So there will be a force Q into E. You can take this distance as x, okay, because this is the position x. And there will be another force here, that will be mg. Mg is also there now. So both the forces must be balancing right now, correct? Mg and q here balancing, there is a equilibrium position. So there is a equilibrium somewhere. We can find out that equilibrium. Let us say that this x is x naught. X naught. Where will be the equilibrium? So somewhere equilibrium is there, right? And if you disturb it from that position, what will happen? What do you think can happen? Hmm? Suppose you disturb it from that position, will it come back to the same position or not? Hmm? What do you think? Suppose first of all you calculate what should be x naught. So if I say that we already know the graph field, there is a particular point where field is maximum. There is a particular point where field is maximum. So if the field is maximum there, uh, because QE is variable along the axis, so at particular point Q is maximum. So what will happen if you take net force? Let us say this is general x, not x naught. Assume that it is x. So what are the forces acting if you try to write the net force? Net force. So net force, let us say upward as positive. So QE minus this mg, right? QE minus mg. So at equilibrium, net force is 0. That we know net force will be 0. So we can find out that value x where it will be, right? So QE is equal to mg. So E is equal to mg by q, and E formula is kq by kqx. X means kqx divided by r square plus x square power 3 by 2 is equal to mg by q, right? Definitely you need to calculate this. This calculation may not be easy, right? Hmm? Because this is power 3 by 2 and other things. How do we know whether it is okay? Equilibrium means we can calculate x, but how do we know that what kind of equilibrium it is? Hmm? How do we know? I think we need to think of the concept of potential energy, because first of all force has to be zero, and another to be potential energy should be minimum. That is the condition, right? Potential energy has to be minimum. So how can potential energy minimum? See, potential energy U has to be minimum. First of all, U has to be minimum, and force also, net force also has to be zero. This is the condition for stable equilibrium. And you know that here what is the net force? Net force is this, we know. Also note that this force, electrostatic force can be written as minus du by dx. Correct? Electrostatic force can be written as minus du by. The potential energy minimum, this is zero. That's right. Also note that if I differentiate this, if I differentiate this with respect to x, it will become minus d square u by dx square. And note that potential energy has to be minimum. So when potential energy has to be minimum, double differentiation, tell me what will be the sign of double differentiation? This you can tell now. If a function has to be minimum, what should be the sign of double differentiation? Yes, double differentiation, forgot? Hmm? Double differentiation is what? What does double differentiation mean? Yes, Kevin, what is double differentiation means? No, no, that is okay. But what is the physical meaning of double differentiation? Maths. Actually, I'm planning to start a course of maths. because lot of students have maths problem. I also have lot of maths problem. So I am doing some work to start a course on maths, particularly for physics application. Like in all chapters, a lot of applications of maths are there in physics, and generally the students they don't have that base, because when they come from grade 10 to 11, that base has not built up maths. That's why. So this thing is basic maths, it is, but in physics there are advanced maths application also come. Even grade 12 topics applications come in grade 11 itself. What to do? So these things should be taught in every applications, right? So I'm planning to start a application oriented course in maths, particularly for physics, in every chapter, everywhere, wherever it is used. I have already started the work on this. Maybe after some time I will start. Okay, so let's see. So double differentiation, single differentiation means slope, double differentiation means shape. Concave, convex, right? Concave, convex, you have studied that. So when maxima you take this convex shape, and at convex shape means double differentiation is negative. and minima means concave shape. Their double differentiation is positive, right? So double differentiation has to be what? For maxima. For maxima, here what we are looking for? We are looking for minima, minimum potential energy. So for minima, double differentiation has to be positive. So this double differentiation has to be positive, positive for minima or for stable equilibrium. Now, if this is positive, this must give us negative, right? This one, that means differentiation of force of electrostatic force must give negative. This you should note. Okay. So, for stable equilibrium, for stable equilibrium, for stable equilibrium, double differentiation of electrostatic force with x, right, must be negative because this term is positive. Okay, so we have got the force. We have got force at an instant. At an instant, force is that. So, what is the net force at an instant? Net force we already know, that is electrostatic force. Electrostatic force minus mg, because they are in opposite direction. So, we can try this differentiation. Differentiation you try. So, even you can differentiate the net force. But differentiation with respect to x, we need to do it, right? Differentiation with respect to x. Okay. And see the net force which is coming, it is in equilibrium, right? So of course this will be zero in equilibrium. What about this differentiation of this? This force is this one, right? This force is this differentiation of electrostatic force with respect to this is a constant, right? Mg, so this will be anyway become zero. Mg is constant. So this is going to be negative. So let us differentiate this and check out what it will get. I think differentiation already we have done it, right? To calculate maximum and minima, we have already done differentiation. But you have to make sure the differentiation should be negative. Okay, let us again do that differentiation. So we are going to differentiate electrostatic force means Kq, that small q, Kq, because field q into E, field formula is Kqx, right? Kqx into r square plus x square power 3 by 2 is equal to 0. Not 0, sorry. This has to be negative. Sorry. You calculate this and this has to be negative. This has to be negative. So can we do that differentiation, and we have to, I think, find out from here what will be that condition. Okay, so try this. Already this term which is constant, you leave that. Kq is constant, so that means x by this, u by v differentiation, so square of this, so r square plus x square power 3 by 2. Now leave this r square plus x square power 3 by 2, differentiate x1 minus, same way leave this, differentiate this, so 3 by 2 r square plus x square power half, then 2x. This must be less than 0. So what will be that? You need to solve it now, I think. This will go that side, and here half factor will get cancelled. It will become r square plus x square minus 2 get cancelled, 3x square. Should be less than 0. So from here 2x square should be greater than r. 2x square must be greater than r. So x must be greater than what? R by root 2, correct? X must be greater than r by 2, right? That is the condition for what condition we have taken. This is for stable equilibrium. So for stable equilibrium, x must be greater than this point. Okay, so above that point only you will be getting stable equilibrium. Are you clear about this? That point is stable equilibrium. Right, I think the point that we are considering, that has to be stable equilibrium only. Above that, of course, negative will also come. I think negative condition can give unstable equilibrium if you take minus condition. I think we'll see some question. You figure out there was a question somewhere related to that. Okay, we'll see that question. Now, next, let us move that. So potential we have done. We have done the field, maximum field, stable equilibrium. These things over. Next, let us go for disk. Disk, uniformly charged disk. So if this is a uniformly charged disk, disk is a two-dimensional body, and this is the axis of the disk. Anywhere, let us take any point again at a distance of x, radius is r. Okay, so you want to find out the field here. So to find out the field here, this whole disk can be divided into small elements. So what kind of element you can break? What kind of element should we break this disk? Yes, what do you think? We can break into small ring elements, because for ring we have already done, so we can use the result of ring. So let us break into small ring. So this is a small ring. Let us say right now this ring has radius small r, and it has got a small thickness of dr. Okay, so definitely it has a small thickness. So what will be the charge here? Charge. So charge of this element dq, that charge can be written as sigma into dA. Sigma is charge density. Sigma is charge density. Area will be 2 pi r into dr. 2 pi r into dr. Okay, this is the area. Now you got this. Now this will be creating a field here, right? This field, again, this is like dE, and you can take this angle theta, but this time theta is variable. Note that, because the ring which you are taking, it is going, right, it is going from angle 0 to that angle, maximum angle, right, up to the final radius capital R. So if theta is variable, so it makes your theta cannot be constant here. So we can write this small d, and also we can write this component. We know only this component will remain, which you have to integrate, because this component d is sine theta component will be getting cancelled, because due to a ring only horizontal component exists. So this horizontal component only we have to integrate. Now dE, we have to first of all calculate what is dE. What is dE? dE is k dq. Or why don't we write the direct result? Because ring already we have derived. We can directly think of writing, instead of doing all these things, right? We should directly try to write, directly try to write the result of that ring. Okay, instead of doing directly, you write this small field due to this ring. This ring is a small element. So we know formula kqx by, that formula. So k q is a small q, k dq, kqxx is this, divided by x square plus r square, x square plus this is small r square. So this we can write as, let us write this as z here. So that is z cube basically, that, because power 3 by 2 comes because of that, right? So k dqx by z cube, that is what it is. And we need to calculate net field. We have to integrate this dE. So k dq now let us write dq. From here you can write sigma 2 pi r dr, right? This time is dq x divided by z cube. Okay, then what else? So this field is going to be integration of constant terms you can take out. So k sigma 2 pi I have taken out, k sigma 2 pi r by z. What is r by z? Small r by z, this is sine theta, correct? So note that small r by z is sine theta and x by z is cos theta, right? So try to convert it. Try to convert it. So you r by z you will write one as sine theta, x by z we will write as cos theta, still one z in denominator will remain and dr will remain. So try to bring in terms of d theta. I think if you try to bring in d theta, then it is possible. How to do that? dr how to write? What do you think? How can we write dr? Huh? Okay, here note very important thing, x is constant. X is constant. Okay, why x is constant? Because this point is fixed where you are calculating the field due to the entire disk. So any small ring you take, this x is constant. So note that, try to bring in terms of x. So I think better you use this one. No, z we can write in terms of z, we can write as x by cos theta. So let us do that. Z we will substitute. Can we do that? Z we can substitute. So E becomes k sigma 2 pi integration of sine theta cos theta z, and dr also we need to substitute now. Dr also we need to break. So how do you do that? I think it is better to write tan theta. Tan theta we can write as r by x. So r become x tan theta, and if I differentiate dr, x will come out. Tan theta differentiation is secant square theta d theta. Yes, I think this is how we can convert. We can convert z in terms of x by cos theta and dr in terms, both you have to do. So z becomes x by cos theta, and dr will become x secant square theta d theta. Now let's see what is going to happen now. So field is going to be k sigma 2 pi, x got cancelled here, cos square secant square become 1, so basically it got reduced. Right, this whole calculation got reduced. Only sin theta integration you have to do now. This you remember, this you have to do, particularly in board exam they can ask. Okay, so now you do that, and we have to go from where to where? Theta, minimum value theta is 0, maximum value will be there, that we will calculate. Okay, so now substitute this, and sine integration is minus cos, so k sigma 2 pi, sine is minus cos theta, 0 to maximum theta. So let us do this calculation. So electric field you got as k value, if you want to substitute, k is 1 by 4 pi epsilon naught sigma into 2 pi, and upper limit minus cos theta max minus plus cos 0 degree 1, right? Cos 0 will become 1. So this field we are getting as 2 pi get cancelled. So sigma by 2 epsilon naught. This cos 0 1 will bring. What is cos maximum? Try to understand this. Suppose this is the disk, and if you take the last element, if you take the last element here, the last means the outermost ring, then this angle is the maximum angle, right? This is maximum angle. So what is the maximum of cos? Because this is x and this is r, and this will become root under r square plus x square. Okay, so maximum value will become, cos maximum value will become what? X by this, x divided by root under r square plus x square. This is the final formula. So field on the axis of a disk, circular disk, is given by this result. This derivation we have done, you should understand clearly. Okay, the main problem will happen how to do integration, how to do substitution and all that. So this thing be clear. Yes, done, clear. Now we can try to find maximum value. Let us try to do the maximum value. So for maximum field, for E max, again we have to differentiate dE by dx has to be equal to 0. So when you differentiate, this is anyway constant, leave that, one differentiation will be 0. Basically you have to differentiate this term. So differentiation has to be 0. So this you can divide, one differentiation is 0 minus differentiation of this. Differentiation of this has to be also 0. So this differentiation basically has to be 0. Differentiation of this. So this differentiation will be what? Again square of this. So r square plus x square. U by v. Leave this root under r square plus x square. Leave this. Then differentiate x1 minus, leave x, differentiate this, root means 1 by 2 root, 1 by 2 root, chain rule, and then differentiation of this become 2x, and this has to be equal to 0. So let us solve it. So you can take LCM, so it will become, this 2 will get cancelled, so it will become r square plus x square minus not coming, this x square. Do we need to do differentiation or not here? Because from here it is nothing coming out. Some constant value will come out. This will go 0. So I think let us do one thing. Little bit rearrange this formula. You can try to rearrange this formula. Before doing all this, no maximum. Let us rearrange this. Rearrange it, because if we can understand how to get maximum, we can rearrange first. Let us take x square common from here. So x divided by root of that x will come, will become r square by x square plus 1. This x get cancelled, so field is sigma by 2 epsilon naught 1 minus 1 divided by root under r square by x square plus 1. I think here we don't have to do maximum minima, because we can understand what is involved here. See here, if you want maxima, suppose you want maximum, if you want field maximum, so you have to subtract this term which you are subtracting should be minimum, and for the term which you are subtracting should be minimum, right? For this term should to be minimum, the denominator has to be maximum. Denominator has to be maximum. And when is the denominator maximum? The denominator can be maximum when When is denominator maximum? When denominator is maximum, what do you think when denominator is maximum? Correct, because you have to subtract it. So you have to subtract minimum. To subtract minimum, this denominator has to be maximum. For this denominator has to be maximum, this term has to be maximum. R square by x square has to be maximum. This term can be maximum when x is very, very small. Are you getting this? So that is why no result came by differentiation. You see that? So you need to analytically do that. Okay. So if x is minimum, let us say x is 0, very, very near to the center of the disk. If x is 0, then this term will become infinity. And if this term become infinity, then almost infinity, right? So 1 by infinity becomes 0, that is the minimum value. That is why don't have to do any differentiation. So directly you can write that e will be maximum. E will be maximum value will be sigma by 2 epsilon, because this term will be 0, and this will happen when x is equal to 0. Okay, clear? This is the maximum will happen. Maximum field will happen when x is equal to 0. You don't have to differentiate this, because from differentiation no roots will come. Okay. Then let us go further. Next, so this is about the field. Then what about potential? Potential also calculation in the same way you have to do. Potential due to disk. Potential due to disk. Same way, this is R and this point is X. It is a uniformly charged disk. What will be the potential at this point? You have to take again a small ring, and due to this ring, a small potential will be there, but this ring will have some thickness, right? So the charge on the ring dq already we have discussed, sigma into 2 pi small r, this is the small r, its radius, 2 pi small r dr. Okay. So due to this, what will be the potential for the ring? We have already seen potential. Potential formula was what? K q dq divided by what? Divided by this distance was there, correct? Which distance? This distance. This distance, which you can say as z. So k dq by z, correct? Okay, you have to again integrate, but this time again this theta is variable. So total potential, if you want, you integrate this dv, that means integration of k dq. Dq is again sigma 2 pi r dr by z. Again here you can try to substitute. So r by dz. So we have just seen, right? So x is equal to, what is x, or what is small r by x? That is tan theta, right? So r was x tan theta. Just now we have done that. So dr we will substitute in the same way. X tan theta is secant square theta d theta. This substitution we have to do for dr. And r by x is nothing but, sorry, r by z is nothing but sine theta. So let us do that. So integration of k sigma 2 pi r by z has become sine theta, and dr has become x secant square theta d theta, correct? Right? K sigma 2 pi sine theta x secant square theta d theta. Am I correct? R by z has become sine. Dr we have written as x. Okay, let us try now. Now what? So net potential will be constant term, take out k sigma 2 pi x is also constant. Now you have to do, this is sine theta. Secant square can be written as cos square in the denominator. Okay. Now what? We need to do substitution. Without that, you cannot solve. Integration by substitution you have to do. So let us say that cos theta I am going to put as some variable I have to put it. Let us put as y. So differentiation of cos theta is minus sine theta d theta, that will become dy. Let us do that. So this potential V can be written as k sigma 2 pi x. Also k you can write as 1 by 4 pi epsilon naught sigma 2 pi x. This sine theta d theta, note that this sine theta d theta will become minus dy and cos square become y square. So this has become easy calculation by substitution. That's how we should learn maths. Okay. So 2 pi, this will get cancelled. So sigma by 2 epsilon naught x. Integration of 1 by y square will give minus 1 by y. Minus minus will become plus. So you will get 1 by y. Okay. Limit of y. So limit of y means theta is limit, right? If you want, you can substitute y as theta. So one step you do further, you substitute y as back as theta, cos theta. So 1 by cos theta, you are going to substitute y, correct? And then what is the limit of theta? Theta is going from 0 to theta is going maximum, right? Now let us substitute that. Okay, right? So substitute this. So V is equal to sigma x by 2 epsilon naught. Uh, Upper limit is 1 by cos theta max, 1 by cos theta max, minus lower limit cos 0 degrees 1. So that is going to be 1. And what is theta max? We have seen that maximum theta means the maximum theta, if you take, this is x and this is radius capital R, this is root under r square plus x square. So cos theta max becomes what? Cos theta max becomes x by root under r square plus x square. We will substitute there. So we will get the potential formula. So potential is sigma x by 2 epsilon naught. 1 by cos means this becomes root under r square plus x square divided by x minus 1. Okay. This is the formula for potential. Potential on the axis, potential at the axis of the disk, uniformly charged disk. Clear? Okay, so today we have done derivation only. Again here maximum minima, you can think you don't have to do any derivation, little bit transform this. Okay, so V is equal to x is also there. No, I think here you have to do x, you can take inside sigma by 2 epsilon naught root under r square plus x square minus x. You have to do differentiation here, I think, because two terms are coming, you cannot directly compare. So if you try to do that with respect to x, dv by dx is equal to 0. This term you leave it, differentiation of this is 1 by 2 root this, 1 by 2 root this, and chain rule 2x minus 1 is equal to 0. So from here it got cancelled. So you got x by this is 1. So x becomes root under r square plus x square. Why no values are coming again here? 1 by 2 root this and then x square is 2x. So what will you get this? This is not possible, right? Sigma by 2 epsilon naught should be x we have taken inside, right? This got cancelled x. When will be this maximum? It is possible. When can we write it? We differentiate root of this is 1 by 2 root this. Then x square differentiation is 2x minus x with differentiation 1 is 0. right? So 1 by this, x by this is equal to 1, x by this factor is equal to 1, x is equal to, if you square, I think we are not able to get anything from here. Check that. Correct? You will not get anything from here, because if you square it, so x square is r square plus x square. This is not possible, no? Correct? Is there any maximum value will exist or not exist? Hmm? Think about it. Okay, next class we'll think about it. But maximum minima is not coming by differentiation from here. If you do the differentiation, we are not getting anything out from here. Okay, right? And if not coming anything, because from here you have to equate to 0. It doesn't satisfy for any value, because any value you take, even if you take 0, it is not possible. If you take any other value, not possible, because x square will get cancelled. That means r square is coming 0. That means r is 0. That is not possible. It has some radius. So maths is tricky. You need to understand what will be the tricks inside math or how to do it. Okay. So we will see that. So we have today derived the important results of field and potential due to a ring and due to a disk. Okay. For disk maximum, we will see if it is existing, then we can calculate. Otherwise, not existing means you can leave it. Okay, so I hope you are working out problems on this, and I have uploaded some 4 5 DPPs I have done uploaded so far. So you are supposed to work out questions on this, right? So I think, but potential topic may not be coming for your upcoming test in your schools, right? So if you want, you can leave it, but you must practice question on force and fields, right?